Greetings. We're going to finish our notes on algebra tiles. We ended with number 3 of solving using algebra tiles. So since I don't have a document camera here at home for me to use with you, I found a wonderful site from Glencoe that offers virtual manipulatives and our virtual algebra tiles. They're slightly different color. If you notice that all the negatives are in fact red, just like our ones that we have in our physical manipulatives, but then the blue ones with the positives are blue, green, and yellow. So just keep in mind that ours are all blue for positive and all red for negative, but they all work the same. We also learned in 277 that there are a variety of different manipulatives out there that we can use virtually. So just because I found this one doesn't necessarily mean it's the best one out there. I just thought it would work best for our individual situation that we're in right now. I'll share this link with you in case you're interested in utilizing this as well. So we have to solve first 3x minus 2 equals 4. So I'm going to pull out 3x values onto my mat here. I was able to choose a background and I chose the equals mat to kind of set it up just as we had earlier in class. And 3x minus 2 is equal to 4. So bringing out 4 positives here. Our goal is to get x by itself or figure out how many wholes go with our x value. So I know if I were to solve this, I would need to add 2 to both sides. So I'm going to add 2 positives to both sides so that I make 2 groups of 0 here. So now that I have those groups of 0, I'm just going to pull them off my mat, get them out of the way so they're not included. Now I have 3x equals 6. So what might be easiest is notice I can rotate these, and you don't have to rotate them, but I just want to move them to see how many singles would pair with each x value. So if I paired here, here, and here, I notice that I have enough such that each x value earns 2 units. So then I can say that x is equal to 2. Now we know that there are many different ways that we can solve and that it's not always going to be a nice whole number. But keep in mind when you're using manipulatives, especially algebra tiles, that when we first begin learning solving 1- and 2-step problems, that we are only going to get, for a little while at least, whole number values. So as you progress, and students don't necessarily need the whole number values or they don't need the physical manipulatives, then you can start working towards the more abstract where you're solving using pen and paper instead of using manipulatives. But keep in mind that when we first begin using whole number results. The next problem we have is 5x plus 6 equals negative 4. So I've got our 5x values plus our 6 units equal to negative 4. So if I want to get our x values by itself, we need to find, and how are we going to get rid of the positive ones here? So we need to create 0 pairs so that they disappear. So I'll need to bring out 6 negatives to make 6 0 pairs. And again, what we do to one side, we do to the other. 1, 2, 3, 4, 5, and 6. We know that these are going to disappear. We've made 6 0 pairs, so then all I would be left with would be my 5 x values equal to negative 10 on the right-hand side. So if I were to pair each one up, now this is the same as we're dividing our units into 5 groups, which is where the division of 5 comes in. The opposite of multiplying is to divide. So I'm dividing my units into 5 groups. so that each group gets -2. So x is equal to -2. Now we're moving on to adding polynomials together. I do not want you to use our rules to add or subtract. I want us to logically think about why we're doing what we're doing as we're going through this. So when I look at 2x squared plus 3x plus 5, I know that I need 2x squareds. I need to add in 3 x's and 5 units. Okay. I want to add to that a single x squared, -2 x's, and -3 units. So I'm adding them in. Now I'm going to look across and see, do I have any 0 pairs? Well, I don't have any 0 pairs with my x squared, but I do have 2 0 pairs with my x's. So I'm just going to set them off to the side here. And it looks like I have 3 0 pairs with my units. So now I know for my final result, I have 3x squareds plus a single x plus 2 units. Now I have 2x squared plus 4x minus 5, and I want to take away -x squared plus 2x minus 3. Now I know you know that you need to distribute the negative and that a negative and a negative is this and that. So I don't want us to do that though. I want to show you why subtraction, why we're doing what we're doing. So I'm going to start off on the left that we have 2x squareds plus we have 4x's and we have 5 negative units. Now I want to take away a -x squared. I want to take away a -x squared, but I can't take away a -x squared. We don't have a -x squared here. So what I'd like to do is then add in a 0 pair, right? So then I have a -x squared to take away. So if I add in a -x squared, or I add in a 0, I now have a -x squared which I can take away, giving me positive 3x squared, and that's how we go from subtracting a negative is a positive. All right, now I want to take away 2 x's. I have 2 positive x's that I can take away. And now I want to take away -3. I have 3 negatives that I certainly can take away, leaving me with 3x squareds plus 2x minus 2.